Hello, welcome. Let's try to solve another Leetcode problem, diagonal traverse. So for this problem, 498 diagonal traverse, it's really easy to understand. We are giving m times a matrix map. We're going to return an array of all the elements of the array in diagonal order. Yeah. So this means, for example, this is 1. It's going to be 1, 2, 4, 7, 5, 3, 6, 8, and 9. But how can we make such kind of a diagonal traversal? Yeah, so this is going to be the difficult part. But normally for a matrix problem, normally we're going to draw a matrix. Let's make it simple. Let's just draw a 3 times 3 matrix to check what's going to happen for this matrix. Normally, if we are going to traverse the matrix, it's going to be row by row and column by column. It will be like this. So this is going to be the basic traversal. But this is not helpful for solving the problem because we are solving the problem according to the diagonal order. And how can we find this diagonal order? We just need some very basic mathematical calculations for the matrix. So how can we calculate? Normally, for this matrix, we have row and column. So for example, this is a row and column, but for this one, this is a 0 and 0, right? Yeah. So let's just put a 0, 0 inside. This means row is 0, column is 0. So definitely this is a 0, 1, and 0, 2, and similarly this is gonna be. Let me make it right. So similarly here gonna be 1, 0, 1, 0, 1, 1. This is going to be the position. Yeah, this is going to be 1, 2. And similarly for here, it's going to be 2, 0, 2, 1, and 2, and 2. Yeah, so this is going to be the position for all the cells. Now, what are we going to do? We just need some very basic mathematical calculations to make it right. Yeah. So for this one, whether we're going to use R plus C, so those going to be R and column going to be C. Whether we're going to use R plus C or R minus C, it is dependent on the problem. Because for our problem, it is this kind of diagonal traversal. If it is like this, so basically we're going to use R plus C. So for this one, R plus C is going to be 0, and this one R plus C is going to be 1, and this is 1, R plus C it's going to be 2, 2, 2, and for this one it's going to be 3, 3, and 4. Now, what happens for our matrix? As we can see, so for this one, this is a 0. This line, it is 1. And for this line, it is always to be 2. And for this line, it is always to be 3. And for the last line, it can always be 4. Yeah, so this means we can solve the problem easily by using the R plus C as the positions of all the cells. So we're going to put this 0 inside a dictionary and put this 1 inside of the dictionary and put 2 inside of the dictionary. Then we just need to check the index. If it is an even index, so we're going to need to reverse it. If it is odd, so for example, this is 1, we don't need to reverse. We can directly get the numbers like 2 and 4. And if this is odd, we can directly get the numbers like 6 and 8. So if it is an even index, for example, this is 2, we need to reverse it. It's going to be 7, 5, and 3. Now let's just use this idea to solve the problem. Yeah. So we're going to prepare the column. It's going to be length of the matrix and the length of the matrix 0. Now let's just prepare a dictionary. So I'm going to use default dict, and inside it's going to be list. And for R, in range capital R, and for C in range capital C. Now let's put everything inside of the dictionary. So the key gonna be R plus C, and we're gonna append a value. So the value gonna be the matrix R and C. So this is the dictionary what we prepared. The next time is that we just need to traverse the dictionary to get the final result. So the final result is going to be an empty array, and let's just check one by one. So for I in range with R plus C minus 1, why? Yeah, because for this problem, as you can see, R equal to 3, C equal to 3, it is 6 minus 1, it is 5. So for our calculation, it is exactly like 0, 1, 2, 3, 4. Yeah, so the maximum index is gonna be 4. So this is r plus c minus 1. It is 5. So this means the maximum index is 4. This is why we're gonna use r plus c minus 1. This is the properties of the matrix. So yeah, now we can check that. So if I modulo 2 equal to 0, because this is gonna be the even index. Basically, we need to reverse it. So it's gonna append the dictionary with this I and reverse. Yeah, if it is odd, basically we don't need to reverse. We can directly get the final result. It's gonna be di. Yeah. So finally, we're gonna return the result. As you can see, it is not so difficult. Everything gonna be really clean if we're gonna try to find a method to use the dictionary to solve the problem. So the method gonna be r plus c. Now let me just run it to have a basic check. It seems it didn't work because I didn't put a 1D array. It should be a 1D array. It is not a nested array. So let me just put a 1D array. So if we are going to use 1D array, we're gonna use extend, right? So we're gonna use extend. Yeah. Now as you can see, it works. Now let me submit it. As you can see, it passed for all testing cases, and it's pretty fast because the time complexity is going to be m times c. So the m and c going to be m times c, m times n. Yeah, I'm sorry, m times n going to be 10 to the power of 4. That is why it's so fast. Thank you for watching. See you next time.